Good morning, good afternoon, good evening, wherever you are on this planet, and welcome to our SETI Live. My name is Frank Marchis. I'm a senior researcher at the SETI Institute, and today we are going to talk about the Martian meteorite, a very interesting one that teaches us a lot about the history and the past of Mars. And because some of you know I'm not a Martian, meaning that I don't study Mars specifically, I invited someone who know about this topic to talk to us about this major discovery that was published in Nature Communication a few weeks ago. Her name is Valérie Perret. How are you, Valérie?
Good. How are you?
I'm good. Did I say your name properly?
It's Baire, so you got it right.
So today we're gonna be in an English city live with a French accent, a bit of it. So I was about to introduce Valerie as a postdoc at the University of Northern Arizona University, but I just found out that she became recently a professor at University of Iowa, and today was kind of your day one or something like this.
Day
So
two, so
day two,
pretty
okay.
new.
So first of all, congratulations for that. It's great.
Thank you.
And yes, let's talk about this interesting discovery. I'm very curious to know a bit more about what this meteorite is, Black Beauty.
Yeah, Black Beauty was a real good discovery for Martian people. So there are a lot of researchers looking at these specific meteorites because it's telling us a lot about ancient Mars. Inside this rock, there are plenty of rock fragments, and they are really old. They are the oldest fragments that we have from Mars. They are 4.48 billion years old, so it's almost the age of Earth and Mars. So they're very, very old. And so, like, understanding the chemistry, the mineralogy of all of these fragments inside the rocks can tell us about what Mars looked like more than 4 billion years ago, and perhaps what Earth looked like. So it's a nice analogs that we do between Mars and Earth because we thought perhaps they were similar at one point in the past. And looking at trying to understand these specific meteorites is really interesting for us because of this.
Okay, before we go in details, to all our viewers, you can tell us where you are watching us from. I see that we have people from New York, Brazil, from Mars, from the Philippines, from Romania, from Riverside, California, Brisbane, Australia. Welcome. We are going to talk. We are talking about the Martian meteorite Black Beauty and what we can learn about the past of Mars from it. So this meteorite, I keep calling asteroid. I'm sorry. This meteorite is coming from Mars. We
Yeah.
100% sure about that?
Yeah, we are. And
Okay.
actually, it has been a debate. So it has been found, I think it was in 2011 or around there in the Sahara. And it was thought to be like a chondrite. So not from Mars. We thought it was not from Mars because it's not looking like any Martian meteorites we have in our collections. So it was kind of a debate at first.
Yeah.
But actually, when we look at the composition of the rock, and if we go in more details and looking at what we call isotopes, it's like really precise chemical composition. We see that it does correspond to rocks that we already have from Mars. So it is from Mars. We're pretty sure of it. And
Okay.
it was kind of like debated at first. Yeah.
Yeah, like every major discovery, there is of course a scientific debate, and
Yeah.
that's the way science works. You have a picture of it because maybe our
Yeah. We
viewers would
can.
like to see what it looks like.
Yeah, perfect. Here it is. So that's the Black Beauty. We call it Black Beauty. You know, it's a beautiful black on the outside, but inside you're seeing like some white, some darker areas. So these are fragments. It's what I said. There are some rocks, small rocks inside these meteorites, and they're really interesting. They are some of them are almost the age of our planet. So when you have that in your hand, you know it's kind of something. It's really exciting.
Did you hold it in your hand?
Well, I went to ASU, Arizona State University, and they have a collection of meteorites, and they did receive a piece of it. So I did hold it in a box, but I did. Yeah, it was something for me. Yeah.
It's something, yeah, it must be something emotional to hold something which is the age of our planet. I remember I hold a piece of the moon once,
That's
and
something too, right? Like
that's
people
something. Yeah,
bring
even if it's
rock
just a
something.
rock, it's still something.
Yeah, exactly.
Okay, and we have people joining us from Chile, from Scotland, from Florida, from Northern California, from St. Petersburg, Florida, Louisiana, Tasmania, Northern Florida. Wow, we have people from everywhere. Everybody wants to hear about this discovery.
That's great.
Okay, so this meteorite came from to us from Mars.
Yeah.
You analyzed the composition, you found out it was from Mars, and then now the question is where exactly it's coming from Mars, which area. So this has been basically this is one of the topic of the publication that you are co-author.
Yeah. So we have around, I would say, 130, like 130 Martian meteorites, which is not a lot, but it's great to have them. We can analyze them, looking at the mineralogy. Like we can understand Mars, how it was in the past, but we don't know where all these meteorites are coming from on Mars. And that's really important to understand the what we call geological context. So where it's coming from, because it can lead future missions to go there and analyze this area in more details. It's just one rock, so it's not a
Mhm.
lot to understand the whole planet of Mars. So we need details of the origin of each rock that we have, but it's hard to do. And so this paper is kind of a first because, based on analysis with supercomputers, artificial intelligence, the author published a previous paper where they pinpointed like almost 100 millions of craters on Mars, and from which some of them could have ejected rocks that now we received on Earth. So this paper is like focused on the ejection site of this Black Beauty meteorite, because it's really important for researchers because it has a lot of value in terms of how old it is, how there is a lot of water in it, and we try to understand why. So knowing where it's coming from was really crucial for us.
Okay, so where is it coming from?
So it's coming from the southern hemisphere. And if you pull up the slide I have here, okay. So do you see my mouse? I don't think so.
No, I don't
No.
see any mouse. Yeah.
Okay, that's okay. So in the middle of the slide, you have Mars, which has weird colors, but it's based on the number of craters that have been found with the supercomputers.
Hmm.
And the kind of fire flame going off Mars is the location where it's coming from. So it's in the southern hemisphere. So actually, it has been reversed, but it's in the southern hemisphere, and it's in an area where the crust, so the thin envelope at the surface of Mars, is pretty thick compared to elsewhere. And it was really important because we knew this area was really interesting for us because it has a composition that is different from elsewhere. It has physical properties that are different from elsewhere, and it's very, very old. So knowing that this meteorite is coming from there, it has been like really something in terms of, oh, we need to go there now. We need to have
Yeah.
a mission, a rover, or something going there.
So its composition. It's I read somewhere that it's called what a brecciated Martian rock.
Oh yeah, breccia. Yeah, so the breccia, it's called like that because there are several fragments in there. It's not
Hmm.
just a rock coming from a volcano. Let's say it's just that inside this rock you have several pieces of other rocks coming from perhaps different volcanoes that have undergone water circulation, but another area than where we find it. So we called it breccia because it's fragments of rocks. So
Hmm.
that's why. But the composition, so in this picture, um, the the yellow Mars on the right side, it's the composition of Mars, and the area from where it's coming from is on the left side, and it's like reddish, and it's rich in potassium and thorium, and that is telling us that this region has experienced something different from elsewhere. And knowing this meteorite is coming from there, we can like send mission there. Now we know.
All right. So the name of the region is Terra Cimmerian Sirenum.
Yeah,
That's the name of the province. But they also said that they identified the crater itself.
exactly. Yeah,
What's the
that
name of the
was
crater? Do you remember?
it's Karatha crater. It's
Ah,
the name of a Western Australian town, and it has one of the oldest rocks on Earth. So that's why it has been called Karatha, because it's an old crater. Like the breccia is coming from there, so that's why they called it Karatha.
okay. So I read in a press release from the university that the composition of the Black Beauty, the meteorite, implies that the surface, this area of Mars, is very comparable to Iceland.
Yeah, it's what I like to say. Um, Mars was thought to be like Hawaii. So
Hmm.
basaltic rocks, all dark, all black, you know. And actually, within this breccia, within this meteorite, we found these fragments that have composition more what we call evolved, and they look like continental volcanic rocks that we can find in Iceland. In Iceland, there are several types of volcanoes. There are basaltic volcanoes. There are others that are what we call more felsic. So you're going to find this composition that looks like a composition of a continent, let's say. And so, Mars, perhaps like this area at least, is pretty diverse in terms of composition. So I like to say it could be like what happened in Iceland,
Hmm.
but we don't know yet. We have to go there and see what it looks like.
Okay. So before we go through to that in more details, we have people joining us from Hudson, Wisconsin. Sorry for the pronunciation. Montreal, Quebec. This one I do it easily. Sacramento, Melbourne, Australia, Puerto Rico. Welcome. We are talking about the one of the recent discovery on the origin and the composition of Mars from meteorite. Okay, so now we have a better idea of the composition of this area of Mars, the surface of Mars. You have been saying multiple times we have to go there.
Yeah.
Okay, so why do we have to go there compared to any other places, and how are we going to go there?
Well, I'm sure other Martian geologists could debate with me on that. It's my, like we know that this meteorite came from there, and we know for sure that there are huge diversity of rocks that we did not expect on Mars before. And that's
Mhm.
why I think it would be great to go there and to compare with what we know on Earth and see if Mars could have been like ancient Mars would have been like Earth a long time ago. Um, there is a lot of water in these Martian meteorites, which we did not expect before. So this had been published in 2013, and that means this area had water. And if it had water, perhaps life could have been, could have happened there,
Yeah.
could have been like thrilled there. So going there and looking at the rocks, the volcanic rocks, and what we call sedimentary rocks to see if there are some traces of ancient life would be, I think, great in the goal of NASA objectives. So I would be more than excited if we could go there for sure. In terms of how, there could be rovers sent in. There is Curiosity, there is Perseverance rover right now in Jezero craters or more north side of the planet. But so a rover could be sent there. But more and more researchers and engineers are working on helicopters.
Yeah.
So with the Perseverance rover, we had these Ingenuity helicopters. Has been amazing how well it is functioning. It is still going on. I think it's 29 flights that he have done. It was supposed to be just one.
Hmm.
So it is really going on well, and people are thinking about sending helicopters on Mars to go to places where we could not think of before because of this. So hopefully, helicopters could also help us to understand what is going on there in a higher resolution, because we have spacecrafts around Mars, and they can tell us also about the chemical composition of the surface, the minerals going on, but the resolution is not high enough to see these kind of small regions at a centimeter scales or meter scale sometimes, where some really interesting diversity could going on in terms of volcanism. So I really hope we go there, but I'm sure, as I said before, other scientists could debate me on that.
Okay. I've ton of questions about this, but we have people joining us some very interesting places. South Florida, from Los Azores.
Oh,
Wow. Forest City in Arkansas, Bangkok, Thailand. We're talking about this Martian meteorite, and how, thanks to this Martian meteorite, we basically have a sample return mission for almost for free, because that's what it is. You get a
that's
meteorite from Mars, you have a sample of Mars for free, and that's
right.
give you a lot of information, right?
Exactly, yeah, for sure. It's amazing to have these meteorites. And again, like knowing the geological context is really important. And with this publication, we hope that future Martian meteorites will be, well, we will know where they are coming from exactly, so that we have a context, we know where it's coming from, we could analyze it more with the spacecrafts around Mars, to have more information about the area, and perhaps like see what is going on at depth, below the surface, or in cracks or craters or this kind of things, to see what is below the surface.
Okay. So you describe a robotic exploration of Mars to get information about those area of Mars. You
Yeah.
know I'm going here, right?
Yes, I
What
am.
about a human exploration?
Yeah, I mean, that would be great. That would be really helpful, because the Curiosity rover landed on Mars in 2012, and so it has 10 years now, since a
Hmm.
few days, a few weeks. Um, but it's I think it drives for 45 kilometers, maybe 50 now. So it's not a lot. Human, we can even like by ourselves just walk on Mars, perhaps one day. Just walk, and in one day we can do like 10 kilometers, like I don't know, 8 miles or something. And after 10 years, I'm sure we would have done like way more than a rover.
Than the rover,
So
yeah.
that would be really helpful, especially if we can then have these samples in a facility where we can analyze them ourselves. Because again, a rover, it's really good, it's great, and we have several instruments on board, but we cannot analyze whatever we want. So we're limited by the instrumentation. It's hard to have um, high resolution instruments, hard to do like specific analysis sometimes. So that would help a lot for sure. When is it happening? I don't know. We will see maybe in the next decade or something, but I don't know when it would happen. Hopefully soon. But
Okay. Well, we have a question from Anthony Monaghan about something that may pop out on the screen here. It's how the absence of magnetic field on Mars will affect the ability of human to stay there or to visit this planet.
yeah, it's a really good question. So the magnetic field on the Earth, for example, it's what help us to survive, let's say, just to live. Without magnetic field on Mars, for example, there is almost no atmosphere. There is one, but it's really thin atmosphere. Um, if there is no magnetic field, you would expect solar winds, which are not good for us at all.
Mhm.
So if we go to Mars without a magnetic field, we would need to build habitats and also clothes for human, um, to avoid solar winds, radiation, or these kind of things that are really bad for us. So yeah, the magnetic field is kind of crucial. In terms of living full time there, that would be a real problem. And that's why a lot of people work on how to create a new magnetic field on Mars, terraforming Mars. I cannot go into details with that because it's not my field, and I cannot really talk about it. But the magnetic field is really important if we want to go there long term, for sure.
Exactly. Or build habitats at least bury underneath the surface, so we are
Yeah,
protected by the temporarily by the magnetic field. But the problem
exactly.
of hiking on the surface of Mars will still remain. We will not be able to stay on the surface of Mars for days. We will,
Yeah, no,
there will be some,
that would be really
except
hard.
we invent an amazing sunscreen that can protect us, but I don't
Yeah,
think anybody have done that yet.
no. Well, there are a few sample of astronaut suits on the Perseverance rover to test the ability of these suits to remain kind of safe for us after a few years.
Yeah.
So we will see what the experiments will tell us about that. But right now, yeah, it's kind of hard to tell.
Okay, another question which is related really to what SETI Institute is all about, by
Oh,
Sandy Bartolotti. It's about the fact that the excitement of finding an actual fossil on some type of meteorite. So it's a statement and the same time the question. But is that possible, first of all? Can we one day trek on the surface of Antarctica and find a piece of Mars and find a fossil in it?
that would be amazing. That would be super debated though, and it happened actually. I don't know if you remember that, but
Yeah, I do remember. I'm that old.
is it?
1995, ALH
Yeah,
something. Yes.
yeah. This Allen Hill Martian meteorite had these interesting shapes of something going on inside, and some researchers said these are fossils.
Yeah.
So there is life on Mars, and it was a huge discovery. Of course, everyone was super excited about it until, well, like other researchers mentioned first, just looking at the shape of these minerals or whatever they were, um, could not tell us that they were fossils. And also, it could be formed just like with chemical elements. So
Yeah.
it's not biology going on there. There is no life going on there. So we didn't find any fossils at the end, but it would be really exciting for sure. I doubt it would happen, or, well, who knows? I mean, like maybe in a few years, with the Mars sample return, we will see what is going on. But we've never seen any fossils in really good location for life to thrive. So that's why I'm saying I'm not sure it will happen. But that would be exciting, though. That was the
Yeah.
question. I would be really excited.
And I do remember that even the president of the United States at the time talked about it. I think it was Bill Clinton, but I'm not 100%
For
sure.
sure.
So please correct me if I'm wrong.
I know.
We have another question about if Cole Calling, sorry for the pronunciation. You mentioned finding water in the rock. Will you postulate the possibility of bacteria hitching a ride and surviving the re-entry to Earth's atmosphere? So having this life on Mars coming to us.
That's a really good question and really interesting. So first, I'm not someone working with bacteria and biology, so I'm not an expert on this. But I would say I doubt they will survive the reentry of in the Earth atmosphere because, like, even the rock, it's firing. It's a ball of fire when it's coming into the atmosphere. So if life is there, it has to survive. I don't know how many hundred or thousand degrees, but a lot. So we would have to be able to survive to that, and I doubt that's possible. But bacteria can be really strong and live in really interesting environments. So perhaps I could not. I don't know, but
Okay.
that's a really good question.
It's very unlikely, but it's possible. And I think one thing that I read is that the water appear on Mars earlier than it appear on Earth,
From what we know.
from what we know. So it may be possible that life appear on Mars before it appear on Earth.
Yeah. So the problem with the Earth is that with plate tectonics, we lost a lot of information, a lot of rocks. So that's plate tectonics is what make the Earth alive, like where life is thriving. Um, so we can thanks plate tectonics for that. But the problem with that is we lost a lot of information of our past, and like life, we don't know exactly when it started. Whereas like I see many papers saying, oh, it's not 2.5, it's 3.5. Oh no, it's 3.9 billion years ago. And like, they are always trying to make it older, but I feel like it's hard to tell because we lost all these rocks. So we
That's
don't know.
unfortunate. We indeed lost all the rocks that the kind
Yeah,
of primitive rocks that were there at the time of the formation of the appearance of life. So
exactly.
we
And that's
don't
why
really
we
know.
go to Mars too, because Mars didn't have any plate tectonics. So it does have all this information that Earth lost. And so we can do like a cross comparison between the ancient Mars and ancient Earth and trying to understand if Mars looked like Earth before and perhaps life with. We'll see. But yeah.
Excellent. So we're almost at the end of our 30 minutes, and I know you're busy today. I don't want to take too much of your time. But what's the next step for you? What's the next big research or results? Can you tell us a bit about what you want to do in the next 5 years?
Well, actually, I'm really interested in this particular region of Mars. Now that we know this Martian meteorite is coming from there, the Terracerum Cimmeria region, I'm really interested in looking in more details at this region. So I used orbital data to do that, um, and I use experiments to do that. So I'm trying to, yeah, to look for some information that we didn't get before because we were not really interested in this region. But now that we know this meteorite is there, I'm sure there will be a lot of details coming up in the next few years about this region.
Good. So you're
Yeah.
gonna advocate for having more missions and probably more like a balloon or an helicopter or a balloon with helicopters on board. Yeah, let's dream.
Why not? I
Why
mean,
not?
everything is
Yeah,
possible if it's feasible.
exactly. And
To
nobody
cost.
has done that yet. So if there is anybody who has some funding here and wants to know what to do with the money and do something that will change the world, well, you should contact Valerie. She has some great ideas.
Yeah, do contact me.
And finding life on Mars will be definitely a revolution. That will be a game changer,
For sure.
definitely.
Yeah.
Even if it's just a fossil, it doesn't matter. But having found that there were life on Mars in the past will totally change the way we see life. And
Oh, yes. It's
yeah,
not just our planet. That would be life changing. Yeah.
life changing. Thank you. Well, thank you very much, Valerie. Thank you to all our viewers here watching us from YouTube, Facebook, Twitch, and more platform. Thank you for watching us. That was a SETI Live with Valerie Perret, who is now a new professor at University of Iowa. And I hope
Thank you.
to come to see you one day over there. I've never, since one of the state I've never been for, to be
Well,
honest.
you should come. I heard it was just cornfields, but it's not just that. So,
You see, I'm waiting for the invitation. If you want someone to talk about
okay.
asteroids, I will be. I will come to see you.
Sounds
Uh,
good.
and yeah, so thank you. And this is the SETI Institute, the SETI Live of the SETI Institute. We are a non-profit organization. We are searching for life, any type of life, even microbes on Mars. It doesn't matter. It doesn't need to be intelligent. It can be a simple microbe. We'll be happy about that to start with. So if you want to support our research, support this program, for instance, you can make a small donation. The link should appear on the screen at seti.org/give now. You can also support us by simply sharing this video, commenting on this video, putting a thumb up, joining the SETI Institute, and getting, for instance, our newsletter called Journey every week. You will find out what we do on a weekly basis about the search for life. And yeah, that's all for today. Today was about Mars. Next week, I forgot what we'll be about. I'm the host, so I should know, but I forgot about it. But I will be there next week to talk to you about another great discovery or great research in the field of astrobiology. Thank you very much, Valerie, again. Bye
Thank you
bye.
so much for having me. Bye.